making or make a plan. In this lesson, you'll learn to use the four-step problem-solving plan to solve problems and to choose an appropriate method of computation. Let's take a look at today's example. Venus Williams is a superstar in the world of tennis. Not anymore recently, probably, but more in the past. Venus learned to play tennis from her father in her hometown in Compton, California. She gives back to the community by giving tennis clinics at public schools near her home in Delray Beach, Florida. Venus spends hours exercising each week to remain in top condition. When exercising, it is important to maintain a reasonable heart rate. Refer to the table below. If you are a 15-year-old, what heart rate should you maintain when you exercise? Okay, so look at the table, and this is the guide to reasonable heart rate at 85% capacity. This is when you are working out or when you are playing sport that involves endurance. Okay, if you are 20 years old, heart rate at 85% capacity should be around 174 beats per minute. 25 years old, 170 beats per minute. 30, 166, and so on and so forth until you, at age 70, the reasonable heart rate at 85% capacity is 132 beats per minute. Okay, we will solve this example or this problem in example 1. Let's learn the concept. So again, to be able to solve problems such as those, we need to use the four-step plan. If you remember, we started the four-step plan in 6th grade, the beginning of 6th grade, and there are 4 steps to it. The explore part, the plan part, the solve part, and the examine part. Okay, let's look at the explore part of the four-step plan. The explore part involves reading the problem carefully. Sometimes word problems need to be read twice, even 3 times before you even start considering to solve the problem. And you ask questions like, what facts do I know and what do I need to find out? And this part right here, what do I need to find out, is probably one of the more important things that you need to know in terms of trying to solve a word problem, because this is what your end product should be. This is what is the purpose of the word problem is. So what do I need to find out? And then the next part is the plan part. So after we found out the facts that we know and what the problem is asking for, see how the facts relate to each other and make a plan for solving the problem. And sometimes you need to estimate the answer to see if it makes sense or not. Okay? Then we solve our problem using the plan that we just created. We solve our problem using that plan. And if your plan does not work, revise it or make a new plan. And the examine part of the four-step plan is just checking to see if your answer is correct or not. We simply reread the problem and ask ourselves, is my answer close to my estimate? Ask, does my answer make sense? And if not, solve the problem in another way. So those are the 4 steps in trying to solve word problems, specifically math-related problems. Okay? And then in example 1, let's go back to example of Venus Williams and reasonable heart rate. So we have at age 20 at 174 beats per minute, age 25 170, all the way to age 70 132 beats per minute. Okay? Find a reasonable heart rate for a 15-year-old. Use the problem-solving plan to find the heart rate. And then the explore part. These are the facts that we know. Okay? The table shows the suggested heart rates for several ages. We are trying to find the heart rate for a 15-year-old, and this is what the problem is asking for, and this is what we will be focusing on, what the problem is asking for. So let's plan to solve this problem. Plan to solve this problem, we try to find an estimate first, make a plan for attacking the problem and estimate the answer. Since we know that the heart rates for several ages, it makes sense to look for a pattern to extend to find the rate for a 15-year-old. We try to find a pattern so that it can lead us to the heart rate of a 15-year-old. Heart rate decreases as the age increases, so the heart rate for a 15-year-old should be higher than a 20-year-old. And then let's take this plan and put it into action by solving it. Use the plan to solve the problem. Find the differences between consecutive ages and heart rates. And look at the top part. In the consecutive ages, you add 5 every single time. And in the heart rate, you subtract 4 from 20 to 25, or 174 to 170, 170 to 166, 166 to 162, and then look what happens. You begin to subtract 5. Then you subtract 4 again for 3 more age intervals, and then you subtract 5. Okay, and then the pattern continues. If you notice, there is a developing pattern. You subtract 4 3 times, then you subtract 5. You subtract 4 3 times, then you subtract 5. You subtract 4 3 times again if this pattern will continue. Follow this pattern, okay, solving the problem. We'll now have, for each consecutive age increase, 5 years, the pattern for heart rate is -4, -4, -4, and -5. And we extend this pattern as follows, and this is what we will get, right? The bottom part, there you go. Okay, so if we increase that, you now have 15, okay, 20, 25, 30, 35, and 40 ages right here. And this will now become 179, 174, 170, 166, 162. Since we are following this pattern, it is logical to say that we're simply adding 5 to 174 to make it 179. So the pattern continues. Okay, so a reasonable heart rate for this exercise is that the 15-year-old is 174 plus 5, or 179 beats per minute at 85% capacity. So that's the heart rate of a 15-year-old if he or she uses 85% of her heart rate capacity. And in trying to check if our answer makes sense or not, compare the answer to the problem and estimate. The heart rate of 179 that we found for a 15-year-old makes sense with the estimate that we did. Our answer makes sense, and the answer is correct. Okay, and that's how you use the 4-step plan to be able to solve a word problem such as the one that we just discussed. Okay, one of the more important steps in solving problems is choosing the method of computation. Diagram below can help you decide which method is most appropriate. Let's look at the first rectangle. Do you need an exact answer? If your answer is no, then we simply estimate. If we need an exact answer, then if we answer yes to that, and then our next question would be, do you see a pattern or a number fact? Okay, so again, if the answer is exact, then we ask ourselves this question. If the answer is no again, then what would we do? There is another question. Are there simple calculations to do? Okay, so after seeing if we don't see a pattern, are there simple calculations to do? If the answer is yes, then we simply use pencil and paper. If the answer is no, then are there any large numbers or many calculations? If the answer is yes, then we use a calculator. Okay, so then the flip side of this, do you see a pattern, number, fact? If the answer is yes, then we use mental math. Okay, so these are a few steps or a few methods we can use to be able to find out the best method for computation or for solving a problem. Okay, let's take a look at example number 2. Modern medicine has made amazing advances in human transplants. The numbers of different types of transplants that were performed in the United States are shown at the right. Find the total number of transplants performed. Okay, so you have a heart transplant, 2,172 times performed, liver, 3,059, kidney, 10,210, heart, lung, 48, lung, 535, pancreas, 557, and this is from the U.S. Department of Health and Human Services. Okay, let's find out how to solve this problem. We are given given the number of each type of transplant and wish to find the total. And this is what, again, what we want to know, or what the problem is asking for. We want to find the total. And in finding the total, okay, we plan to add the numbers of transplants to find the total. Use the diagram above to find the appropriate method of computation. Okay, so the diagram right here, okay, is what we were looking for right here. And in trying to solve this problem, oops, gone, okay, we now have, okay, since we need an exact answer, we will not solve using estimation. There is no pattern in the numbers, and there are many calculations to be performed, so using a calculator may be the best choice. And that's how you use your diagram. We need an exact answer because it does not ask for an estimate. The best thing to do is probably using a calculator. So even though we will solve using a calculator, it is good idea to estimate the first so that we may know whether the answer we find is reasonable or not. Round each number to the nearest 100, and then we simply add mentally. So 2,172, we round them all off, becomes 2,200, 3,059, 3,100, 10,200, an estimate for 10,200, 48 rounds to 0, 500 is rounded from 535, and 557 to 600. We round the numbers to the nearest 100, hundreds place. Okay, 16,600. Okay, now a good question would be, do you think the estimate is higher or lower than the actual? Okay, and if you look at these numbers, this was rounded up, this was rounded up, this was rounded down, down, rounded down, and rounded up. Okay, considering from what we know, okay, I would suggest that I would think that the estimate would be higher than, the actual answer would be higher than the estimate, simply because of the numbers that were rounded up were bigger. 2,172 was rounded to 2,200, and this was rounded to 3,100. Okay, let's find out. So using this, we solve this, and we use a calculator because that was the method that was implied when we were trying to solve the problem. Okay, the best method to use. We simply add those numbers, end up with 16,581. Okay, I'm actually wrong. The number is lower than the estimate. Okay, so the total we found with the calculator is very close to our estimate, so the answer is reasonable. So 16,581 is the exact answer. Our estimate is 16,600. Okay, and from there we've concluded our first lesson of this book. And on Google Forms, type a summary of what you've learned by responding to the objective or objectives of the lesson. Type a question you might want to ask about this lesson. Thank you.